We will now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in December 2023. This question is related to the concepts of second order ordinary differential equation with variable coefficients. The question is from part C, carries 3 marks with the question ID 704093, and it is from part C. It is a multiple select question and there can be more than one answer. The given question is: consider the initial value problem x square y double prime minus 2x square y prime plus 4x minus 2 in brackets multiplied by y is equal to 0 with the initial condition y at 0 is equal to 0. Suppose that y is equal to phi of x is a polynomial solution satisfying phi at 1 is equal to 1, then which of the following statements are true? Which of the following statements are true? We are given 4 options. Option 1, option 2, option 3, option 4. Agreed. Let's now discuss the solution of the problem in detail. So, we are given a second order ordinary differential equation with variable coefficients x square. The coefficient of y double prime is x square. It's a variable coefficient. And the coefficient of y prime is minus 2x square, which is variable coefficient. The coefficient of y is 4x minus 2. So, at least one of them is a variable coefficient, then it is sufficient, and it is called an ordinary differential equation with variable coefficients with the given initial condition. Agreed. Let's take this. Now, we want to put this in the standard form. So, divide throughout by x square. Right. If you do that, then you will get y double prime minus 2x square by x square is minus 2 into y prime plus 4x minus 2 by x square in brackets multiplied by y is equal to 0. It is a homogeneous equation, by the by. It is a homogeneous equation. It is not non-homogeneous, it is a homogeneous equation. So things will be easy when if you find that it's a complementary function, that is sufficient and that itself is the general solution. But anyway, we are not concerned with that. So now let us look at the question. Y is equal to phi of x is a polynomial solution satisfying the condition phi of 1 is equal to 1. If you look at the options, if phi of x is equal to x, if you take, then phi of 1 is equal to 1, then phi of 2 is equal to 2, phi of 3 is equal to 3. If phi of x is equal to x satisfies this differential equation, then your answers will be option 2 and option 4. If phi of x is equal to x square, which satisfies phi of 1 is equal to 1, and if it satisfies the given differential equation, and phi of x is equal to x square, phi of 4 is 16, phi of 5 is 25. Therefore, then option 1 and option 3 are the solutions. It is only a kind of a sort of a guesswork that we are making, and such type of guessworks will help you, and you can manage the time because time will be very short. Otherwise, if you want to do it, it will take a long time. So, recall, we have studied in our MSc classes, y is equal to x to the power of m is a solution of the standard second order homogeneous linear differential equation y double prime plus p of x, p is a function of x into y prime, plus q of x into y is equal to 0. This is a solution. You can very easily do it. Now differentiate once, you will get m into x to the power of m minus 1. If you differentiate twice, y double prime is equal to m into m minus 1 into x to the power of m minus 2, and substitute in this and simplify. Then you will get if m into m minus 1 from here plus mx into px from here plus x square into q of x, y is x square, and there is a term x to the power of m minus 1 will be get. We have cancelled that one, and so that is the condition. So now take let phi of x is equal to x to the power of m, as a kind of a guesswork what we did, and then phi of 1 is equal to 1. Then one may ask a question, why sir phi of x is equal to x to the power of m? It is a polynomial. It can be a big polynomial like ax to the power of m plus bx to the power of m minus 1 plus so on and so forth. It can be like that. But it's a kind of a guesswork that we are making, and we are proceeding. So then phi of 1 is equal to 1, and now y is equal to x to the power of m is a solution if this is the condition, m into m minus 1 plus minus 2 into mx, because in our case p of x is minus 2 and q of x is 4x minus 2 by x square into qx is this one, right? So in our case, so y is equal to x to the power of m is a solution if this condition is satisfied, and further simplification will give you m into m minus 1 minus 2mx plus 4x minus 2 is equal to 0. If it is so, then y is equal to x to the power of m will be a solution. We continue in the next slide. Yes, that's what we have done. Let m is equal to 1. If you take m is equal to 1, so this will be 0. This will be minus 2x plus 4x minus 2. Is it 0? No. See, identically equal to 0 you should get. So it is not 0. It's not 0. In other words, y is equal to x is not a solution of the given differential equation. If you do not want to go by this condition, get into the differential equation and substitute y is equal to x there, then it will not satisfy. Therefore, it's not a solution. So y is equal to phi of x, that is equal to x, because x to the power of m is equal to 1, phi of x is equal to x is not a solution. And let's look at our options. Phi of x is equal to x is not a solution, then phi of 2 is not 2, and phi of 3 is equal to 3 is also not true. So because phi of x is equal to x is not a solution, then we can't have phi of 2 is equal to 2 and phi of 3 is equal to 3. So therefore, the options 2 and 4 are not true. Okay, we are left with m is equal to 2. Let m is equal to 2. Substitute m 2 into 2 minus 1, 2 into 1 is 2, minus 2 into m is 2 into x plus 4x minus 2. So here you have minus 4x plus 2 minus 2 cancels, and it will be 0. It will be 0. That means y is equal to phi of x is equal to x square is a solution. If phi of x is equal to x square is a solution, phi of 4 will be 16 and phi of 5 will be 25. Yes. So options 1 and 3 are true. So now the answer to this question is option 1 and option 3. And in this question we have made an observation of the given differential equation, the given differential equation, and we have observed the options, and we have made a kind of a guesswork that y is equal to x to the power of m can be a solution. Then we have asked for what values of m is equal to 1 and 2. This will be a solution. So we got it. So that is a kind of a cutting short, the procedure of finding the solutions. Right. That kind of things you have to make in such a competitive examination to save the time. So that is the detailed discussion of the solution of this problem, which is based on the concepts of second order ordinary differential equation with variable coefficients. In our case, it is given to be a homogeneous equation. I am sure that you have understood the solution of this problem, and if you like my videos, please like, share and subscribe. I wish you all the best. Thank you.